A lot of people tend to get scared by inequalities because the inequality symbols are weird and scary looking, but they're really not that different, especially when we solve, they're not that different from equal signs. And so, in fact, when we actually solve an inequality, we're going to treat this sign like it's an equal sign. We're not going to change it, but we're not going to do our steps any different until we get to the very end. So the first thing we're going to do is, our goal is always to get our variables on one side, our numbers on the other. I like to get my variables on the left side of the equal sign, but there is nothing wrong with moving them to the right. Either way is an acceptable and appropriate strategy. I like to get them to the left because when I read an inequality that has x greater than something, that makes more sense to me. It also makes it easier to graph, it makes it easier to interpret. But you may see inequalities written the other way, it's not wrong. So for my purposes, I'm going to start by getting all of my x's on the left side of the equal sign. So I've got a positive 9x. If I separate out my terms and look, I have a positive 9x here on the right side of my inequality. I want to subtract 9x from both sides to move that 9x off of this side of the equal sign. What I'm left with is 19. Negative 2x minus 9x is negative 11x. My inequality sign comes straight down, and then the negative 14, which was left behind on this side, also comes down. So now that I have all of my x's on the left side, I want to get all my numbers on the right side. So again, when I separate out my terms, I have this positive 19 sitting here. Well, to get rid of positive 19, whoopsie, I subtract 19. Okay, and that gives me negative 11x, because that didn't do anything, I brought it straight down, greater than or equal to, and this is negative 33. Now that I've got all of my x's on the left and all of my numbers on the right, I can multiply or divide to solve for 1x. Well, since I've got negative 11x's, I'm going to divide both sides by negative 11. This is when an inequality becomes different. If the number that I'm dividing by, meaning this number here on the bottom, is a negative, then I immediately have to flip my sign, okay? And that leaves me with x less than or equal to 3. So, there's a couple of ways I can check this answer. There's no reason to not check my answer. I can pick a value that is less than or equal to 3. I could pick a 3 and I could substitute back up in here and see if what I get on the left is greater than or equal to what I get on the right. I could also choose to solve this by using my calculator. The calculator steps are a little challenging, but it's not impossible to do. So let's take a look and I'll show you how we would solve this in our calculator. The first thing you're going to do is obviously turn your calculator on, clear out all that stuff. We're going to go into y equals, and we're going to put whatever is on the left side of the equal sign here in y1. We're going to put whatever's on the right side of the equal sign here in y2. So the left side I'm going to put 19 minus 2x, and then on the left side, in y2, I'm going to put 9x minus 14. And then I'm going to hit second graph to look at the table. Now, this all looks like crazy, but what we're looking for is we're trying to verify our answer. So we think the answer is x is less than or equal to 3. So we're going to scroll up to 3, and we're going to look at that row there. So, okay, pretend that didn't happen. I'm going to just kind of sketch that little table because I can't write on my calculator, but there's some things I'm going to want to jot down. I want to look at the row, so I think it's 3. So I'm going to look at 2, 3, and 4 in my calculator. Okay, so 2 is 15 for y1, 4 for y2. 3 is 13 for y1, 13 for y2. 4 is 11 for y1, and 22 for y2. So now that I see this, I'm going to look at this a little bit more closely, and I'm going to think about what this means. Okay, I think my answer is x is less than or equal to 3. So on this row right here, y1 and y2 are equal. When y1 and y2 are equal, that tells me that my solution includes x equals 3. If I look up here, 15, is that greater or less than 4? Well, 15 is greater than 4. 4 is less than 22. If I go back to my original inequality, I wanted y1 to be greater than or equal to y2. If I look here, this is greater than, well, this is equal to, and this is greater than. So values that are less than 3 or equal to 3 make this inequality true. I know that's a little weird, but that's how we check it in our calculator.